Known unitary transformers. Must stop talking. Unitary transformers. Over there below, in left hand side, transformer, a colon, single phase transformer, single phase transformer, construction and working principle, single phase transformer, a hyphen, construction and working principle, construction and working principle, a hyphen, types, types, EMF equation, EMF equation, and equivalent circuit. Types, the EMF equation, and equivalent circuit. Equivalent circuit. The last application of transform. Application of transform. Equivalent circuit, then application of transform. First we will be studying about, first we will be studying about a single phase transformer, okay, its construction and its working principle. Then we will be studying about its types, okay, then EMF equation, how the equivalent circuit will be, and last where the applications of the transformers will be. Okay, and first, before getting into the construction working principle, have you all not seen the transformer? You might have studied a basic thing of transformer. Okay, under what principle transformer works? Because that is type of transformer. It comes under step down transformer, step up transformer, being an ideal transformer, how it is a response, and then there is an auto transformer, we will be saying it as area. Okay, so that another comes under types of transformer. Before that, can you ever notice that principle, working principle of a transformer? What laws can be applied there? No. That is laws. Okay. So I am asking about law. So that is electromagnetic induction principle. Okay, the working principle of transformers, electromagnetic induction principle. Okay. In last unit, what we have seen? We have seen electromechanical device. Which is differentiate. Listen carefully. Basic should be very strong. Okay. Definition said to be what? Electromechanical device. Electromechanical. That is some mechanical parts. We are giving what? Electrical energy. It is being converted into mechanical energy. That is a form of motor. If you are giving mechanical energy, if it is converted into electrical energy, that is said to be generator. Okay. That is electromechanical device. Here it is electromagnetic device. Okay. So we will be having a magnetic core. Three parts there. Okay. One is the magnetic core over there. Then the windings, and finally our load. Okay. So for this magnetic core, how it is made? It is made up of magnets. Okay. That is an iron core magnet. Okay. Then the windings. The windings are made up of copper. Okay. So now, as I already told, it works on what principle? Electromagnetic induction principle. So what is electromagnetic induction principle, which we have studied in your physics? Faraday's laws of electromagnetic induction principle. What it is?
The magnetic field produced by the magnet is called as magnetic field.
And then whenever a
Magnetic field induction produced
conductor, whenever a conductor, current carrying conductor, okay, whenever a current carrying conductor is placed in a magnetic field, it experiences a magnetic force, and what happens? An EMF is induced in it. Okay, by that means of what is happening? From one circuit to another circuit, there is some transfer of what is happening? Flux. Okay, so here now two circuits are there. One it is will be setting it as primary winding, and the other one is will be saying it as secondary winding. Okay, as I said, transformers. First, what you have to know about the transformer? Transformer is a what device? Electromagnetic device. Okay, what it has? It has a iron magnetic core as well as copper windings, which is connected to the load. Okay, so next what you have to say that the principle of working of a transformer. What it is? Under And what is the principle? Whenever a current carrying conductor, okay, where is the conductor? This magnetic iron core. This is the current carrying conductor. Is placed in the magnetic field. Okay, whenever this now this is carrying a current. Okay, so there is we are giving an alternating current over there. This current carrying conductor, where this thing being in a, the flux is being produced there. Okay, so what is happening? EMF is induced by that means. What is happening? From one windings to the other windings, the power is getting transferred. Okay. Overall, in the previous unit, we have studied it as converted. Clear? The electrical energy is converted into mechanical energy. Here, what we have to say? Here, from one windings to the other windings, the current what is happening? It is transferred. Okay. So it is transferring from one, that is said to be transformer. Okay. So transferring from one windings of the circuit to the another windings of the circuit. Okay. By means of what? By means of flux. Okay. So now we are providing alternating current to the primary windings of the transformer. That is said to be the input side of the transformer. Alternating current is given to where? Primary winding side of the transformer. Okay. So why can't we give a direct current over there? Why we are giving alternating current? Why should we not give the direct current, DC current to there?
Transformer it will stabilize the current and it will produce the
It will be stabilized. And what is the purpose of stabilizing? So listen carefully. We will be giving the alternating current as an input to the transformer. We won't be giving direct current because in direct current there is no such principle of electromagnetic induction. Clear? You can note this. We will be giving what? Alternating current to the input side of the primary winding of the transformer. We won't be giving direct current, DC current. We won't be giving to the transformer, and the transformer won't work under that principle because transformer working principle is electromagnetic induction. DC current doesn't having that particular principle of electromagnetic induction. Okay, only the alternating current has the principle of what? Electromagnetic induction. So alternating current is given as the input of a primary winding of the transformer. So now we are giving an alternating current to the primary winding of the transformer. What is happening now? Now the current is being produced to the magnetic iron core. Then what is being produced? Flux is produced. Then the flux, what it will do? Now the alternating current is given to the primary winding of the transformer. What is being produced? Flux is produced over. This flux, what happens? It will transfer to the through the magnetic iron core. It will transfer and then it will reach where? To the secondary windings of the transformer. Okay, there is, we will be saying it as n number of times of primary winding and n number of times of secondary winding. Okay, so the secondary winding, what will experience? It will experience the flow. Now here alternating voltage, we will be giving it in terms of what? The constant, as I said in the first unit, the voltage is where? It is from a place of constant. Who is going to flow? Only the current is going to flow. Okay, so here the voltage will either it will rises. For what purpose we are using going for a transformer is only to do the voltage levels up or else down. Okay, so based on this I am saying that number of times, right? Here the primary winding is the n number of times, which is a copper wire which we have bonded. Okay, so here n number of times here in the primary winding and n number of times in the secondary winding. Okay, so based on this number of times of the primary winding and the secondary winding, the voltage levels can be up or else the voltage levels can be down. Okay, so if let me name it as the primary windings transformer number of times as n suffix 1 and the secondary windings here it is n suffix 2 number of times. Okay, if n1, that is the number of times of the primary winding, if it is greater than number of times of the secondary winding. For example, I am drawing that alone. Okay, there is the number of windings of the primary. This is primary, which is n1 number of turns. Okay, so it is being isolated. Okay, I will tell you that isolation later. Before now, the N2 number of turns. If the windings here number of turns is lesser than the primary means. Okay, N2 number of turns is lesser than the primary means. This is determining what means the voltage level is getting reduced. Okay, that is the level is getting lower down. Okay, so it is step down transformer. Clear? And now, if N1 is less than N2, that is here N1 has a lesser number of times being isolated, and the N2 has the more number of turns in the winding. Then it is what the level of voltage is getting up. That is increase or step up transformer. Okay, that is how we will be differentiating the types of transformer as step down transformer and step 2 transformer. Okay, initially first we have to say that what alternating current is being given to the where primary windings of the transformer, what is being produced, flux is being produced, that flux is what it is doing, it will cross or it will transfer through where the magnetic iron core and it reach where the secondary windings of the transformer. What is happening in the secondary winding of the transformer? What is happening? The voltage level is getting up or down based on the number of times of the primary as well as the secondary winding. If we take n suffix 1 as the number of times of the primary winding and n suffix 2 as the number of times of the secondary winding, how the relationship between. Okay, if n1 is greater than n2 means the circuit will be schematic diagram will be like this. Number of windings of the n1 which is greater than the n2. Okay, that type of transformer is said to be what? Step down transformer. The voltage level is getting increased or down. Okay, and if N1 is less than the N2, like this. Okay, the number of windings of the N1 is lesser than the number of windings in the N2. Then the voltage level is what? It is getting step up. Okay, so it is a step up transformer. Okay, we are clear up to this, and now. So now the flux is being produced. Okay, and now next what another comes. What you have to note things means the voltage levels only will step up or down. The voltage level only will vary. Okay. What about in AC? What about the another one specification being present there? When you are marking an input side, phase neutral, we will be marking in phase neutral 230 volt AC supply. Along with that, we will be marking one more thing. What it is? Frequency. Okay, the frequency of what kind of frequency is there in the primary winding, the same will be in the secondary winding. Frequency won't change. Okay, if it in India, the frequency of an alternating current is what? 50 Hz. Okay, while we take it in USA, UK, all it is 60 Hz. Okay, the plug point shapes and their applications and their windings, everything different from us. Okay. So here it is what the standard frequency of ours is 50 Hz. Okay, so the same 50 Hz will remain the same in the both the primary windings and the secondary windings. It won't change. Only the voltage levels will change. Okay, and now I am saying that the EMF is induced, right? Okay, so we will be calculating that in the EMF equation. Okay, now I am saying in the introduction part only I am covering everything. Okay, so that is E root mean square value of it. Okay, that is the EMF which is induced, the root mean square value of it. How will be means the formula will be like it is 4.44 frequency into the number of turns into the flux which is being produced. Okay, the EMF how it is 4.44 is a constant. We will derive it later. Okay, the EMF equation we will be deriving it later. That is the frequency into number of turns into flux at phi. Okay, this is how we will be calculating the EMF equation. We will see it as a small derivation. Okay, and after that, where we can apply in this transformer? In last lab when we are doing a rectifier, motor, what is the purpose for transformer? Last before class of halfway rectifier. Then you have seen. Okay, what is comes under from plug point? We have given the connection 230 volt is there. Just straight away from the plug point, that is where what value is this? 230 volt. There is a small transformer in it. Okay, what it is doing? What is the output of it? Same AC. Transformer won't convert anything. That's what I'm saying. Transformer just transforms the voltage from one primary winding to the secondary winding. Either it will maintain the same level, means it is said to be an ideal transformer. If the voltage level never decreases, never increases, then it is said to be what? Ideal transformer. If the voltage level decreases, means it is said to be step down transformer. If the voltage level increases, means it is said to be step up transformer. It won't convert anything. Okay, keep in mind. It won't convert anything. Okay, it will just level of the water. Sorry, level of the voltage can be increased or decreased, or transfer of electrical alternating current from one circuit to the another. Transformer performance only this. Okay, that is transfer of electrical alternating current from one circuit to the another. It won't convert anything. Okay, this transfer of alternating current from one circuit to the another by the levels of the voltage can be changed. Either it doesn't change, means then it is said to be an ideal transformer. Step, if it is lower, means step down. The voltage level is higher, means step up. Okay, keep that in mind. Its working principle is electromagnetic induction principle. You know that principle very well. That is, here is a current we are giving as an input to a carrying conductor. Okay, what is being produced? Flux is being produced.
Actually, you said doing experiments. And step up transforms, after rectifier, it act as a step up transform.
No, listen, I will tell you. Okay, so there we have seen experiment that is half-wave rectifier. Okay, so there what we are giving 230 volt to a small transformer. It is converting into how much volt? I told you the specification. I have told you to mark that in the transformer. I asked you to see the nameplate of the small transformer. How it is being marked? 9 volt. The center point is 0 and the other point is 9 volt. So the 230 volt is stepped down to how much volt? 9 volt. The 230 volt is stepped down to how much of it volt? 9 volt. This 9 volt, next to what we are placing here? A diode. We are placing a diode. Okay, so that is a rectifier circuit. Okay, that is when we are placing a diode rectifier next to the transformer, means what is happening? This 9 volt AC, this 9 volt AC only, which is step down. We are using a step down transformer. Okay, now this 9 volt AC is converted into DC by that diode rectifier alone. Okay, the diode rectifier only converts AC to DC, not the transformer. The transformer, there your experiment shows for what purpose it is being there, to step down the voltage, because your diode rectifier is a small electronic element. Okay, it's a small element. What it is doing? Just converting a small element, it will convert in a minimum amount of voltage. Okay, it won't convert a 230 volt into as a DC. It won't convert that. A minimum amount of voltage only it can able to convert. So we have step down that using a step down transformer. Then after that we have make it to convert that into a DC by using a rectifier. Okay, so by using the rectifier, now it is converted into DC. Okay, so in DC means everything will come under the graph only. In graph, if you want to say, it will come into the first quadrant. Okay, in the positive side. Since it is a DC, so it will be like this only. It should come here only, since it is DC. If it is a straight DC, then it is said to be a without loss. But we have just converted what? That alternating current of 9 volt in our experiment. Okay, 9 volt is being converted into DC. Where should it come? Only with the positive here. Okay, so if this wave is continuous, means what it is? We have made it continuous. For that, how many number of diodes we have connected? The diode rectifier 2. Both the cycle it will act from 0 to pi as well as pi to 2 pi. Okay, and for this we have converted only one diode. One half cycle will convert. The other half cycle will what? It remains same. Again, when it comes to that mode, again it will convert. Okay, this is the work of half-wave rectifier, and this is for full-wave rectifier. Now, if you see this, everything is a what? It's under one quadrant, which is a DC. Okay, so with ripples. Okay, in further, if you have to study in deeper means these ripples can be eliminated by using some controllers and all that things. Okay, the number of pulsation, that all in deep we need to study. Okay, basically this is the thing. It is AC is converting into DC by using a rectifier alone. There the transformer is used for just to step down the voltage level. The like 230 volt is there, that has been stepped down to 9 volt using a step down transformer, which is a small core. Okay. One thing I told you that I will say about this isolation, right? So if it is a small machine, okay, if it is a small transformer, okay, what kind of isolation it is being used means first where the isolation there is an isolation between primary winding as well as the secondary winding. It will be isolated, or we can say that it will be insulated. Okay, it should not touch each other. Okay, it should be separated by some means. Okay, likewise the windings here. Okay, the number of turns in the primary windings as well as the number of turns in the secondary windings. That is also being isolated. Okay, how this windings being isolated means it is by means of varnish. Okay, it is just varnish with 1 to 1 turn. Okay, and how this primary winding and the secondary winding being isolated means if it is a small voltage level transferring transformer. Okay, just a small level of voltage has to be transformed by using a small applicable transformer means the isolations may be used as either it is a gap. There is no need to place anything over there. Okay, either a gap or it can be just a small piece of any paper like that. Okay, so if it is a high voltage transforming transformer, okay, so higher level of voltages we are going to apply what higher level of transformer, which we have seen in the while we are walking through the road we will be seeing a transformer, right? There what kind of isolation will be used means mineral oils. And what kind of isolation used? Oils will be used, which is a here notice something, right? Either if it is a small voltage level of transformer, this might be a air. Okay. So if it is a large voltage level of transformer, this might be what? Oil. That's it. This mineral oils. Okay. This oil has a multiple purpose. Since it is transferring what? The transformer is doing a higher voltage levels. It is increasing or decreasing the higher voltage levels. There is a possibility of heat over there. This oil will cool down that heat also. Okay, for cooling purpose also it will be helpful. So what isolation we are using in a higher voltage level of transformer? Mineral oils. For the lower voltage levels of transformers we are using is a either air as a medium to isolate. Okay. That is I said large transformer. Okay, large voltage level rising or with voltage leveling transformer. Okay. So as I said in generating station, what it is there? How much of kV is being generated at stations? First class lo kada mari onu sonnai. It is about keep in mind 13.2 kV. Okay, or they will be mentioned 11 kV in standard. In general, in standard values, they will be generating of about 11 kV or 33 kV kilovolt. kV kilovolt. Okay, 11 kV or 33 kV. More than that also being generated. That is as 66 kV or 132 kV. Okay, but we won't go for that higher amount of generation because generating station is a bulk thing. Our generator should be a bulk product, so we won't get enough space. We will be generating about 33 or 11 kV in standard. Then what we will be using means we will be using a step up transformer, a higher voltage leveling step up transformer. What it will do means this will step up that level of voltage. As I said, it's generating what? Just 11 kV or else 33 kV. Now we are going to apply there what? Higher voltage levels transformer, that is a step up transformer. Now what happens? This 11 or 33 kV what it can do? Now it can step up. It can step up of about 132 kV. So no need to generate 132 kV, right? 11 kV if I generate also என்ன ஆகுது 132 kV ஆல என்னால ஸ்டெப் அப் பண்ண முடியும். ஸ்டெப் அப் டிரான்ஸ்ஃபார்மர் ஹையர் வோல்டேஜ் லெவல் ஸ்டெப் அப் டிரான்ஸ்ஃபார்மர் தான். கரெக்ட்டா? சோ அதனால இந்த 132 போய் ஜெனரேட் பண்றதுக்கு மூலமா that is all that's also reason. So one thing we have to notice that we have seen a generator. Okay, before last minute we have seen generator. That is a electromechanical device. There, what it is having? That is having a rotating part. So what is happening there? We have seen multiple losses there. Due to friction, due to rotation, due to air windings, conductors, everything. Okay, that would be happen in case of a transformer. Okay, the losses is very minimal in transformer. Okay, because if the losses is very low, what about the efficiency then? The efficiency transformer is comparatively higher. Okay, so in the generating station, I told you, right? In the generating station, we won't go for a bulk amount of kilovolt generation. We will be generating in either 11 kV or 33 kV. Then we will be using what? Step up transformer. Why we are going for this electromagnetic device means here the losses is comparatively low. There won't be any excessive losses compared to the generator. Generator having what? Rotational parts, friction is there. Due to that, losses are more in the electromechanical device. Mechanical device. This is electromagnetic device. Here there is no friction. Only the transferring of voltage level. If we inject a 33 kV to a primary voltage of the transformer, that is being stepped up to a 132 kV of what mean 132 kV standard values these are all. Okay, 132 kV of voltage level it can be raised. Okay, so in order to minimize the losses and in order to maximize the efficiency, we will be going for a transformer for the transferring of voltage levels. Okay.